Yep.
Few minutes.
I think folks will be at it. Well, welcome everybody. We're having this is becoming a regular event now. Thanks to Allison for pulling all this stuff together. I'm not going to really, there's not too much setup needed. I think Allison's going to go through things and I'll let her take it away.
Yeah. Well, thank you all of you for joining today. This is our third digital transformation webinar series. And so we've continually increased in our attendance over the course of those three. So we are on the right trajectory. Our mission and our vision for this webinar series is not necessarily to speak specifically about one particular technology. There are so many great technologies out there. There's a lot of smart people working on digital and digital transformation. What we really want to do is bubble to the surface how challenging this really can be, not only for an individual human, an individual team, or an individual company, but for an industry. And when I talk with people who are involved in these projects, everyone, it is growing pains that everyone seems to be feeling. And so when Jim and I were kind of talking about what we would do here, it's really to bubble to the surface how hard this can be sometimes, and really start talking about the culture change it takes to truly digitally transform, and that people really matter as a part of this, and then how we can help technology, well-built and well-done technology, relieve some of that pain. So we want to help our industry accelerate and evolve through this digital transformation. And our vision, again, is to really raise a dialogue about this whole software digitization thing and what it really takes. So today's topic, Luther Burzell is joining us, succeeding with AI despite the 85% GASP project failure rate. He'll talk for 20 to 30 minutes. We'll take about a 5-minute break. And then Raji Gajula from Pioneer and Chris Kettner from Phase 2 Development will be joining Luther on a panel where we will open it up to the audience for questions, dialogue. Luther, Raji, Chris, thank you all for taking the time to join us today, and for engaging in dialogue and for sharing your thoughts and perspectives on this whole digitization thing. With that said, Luther, I will turn it over to you, and the floor is yours.
Great. So I remember to take it off mute this time, and if someone on can just confirm that they can see the slides.
Yep, you're good to go, Luther.
Okay, great. Thanks so much, Allison. So thanks to everyone for joining in today. Really a treat to be sharing these thoughts with the International Association of Directional Drilling. So I've been operating OAG Analytics, which was an oil and gas focused data analytics and AI firm from 2013 through the end of last year. And through that experience, I got a lot of exposure to energy tech, worked with oil and gas companies and some mining companies of all shapes and sizes. The 15 years plus of my career prior to that, I had spent doing traditional software, primarily with Fortune 500 and Global 2000 companies. So over the past few months, as I've been reflecting on my experience doing AI with the energy industry, and career and experience in especially in best practices of what really made software work in some organizations and not in others. And then I read this Gartner article that 85% of AI projects are failing to deliver the business value that rationalize the budgets that started the projects. Three of the fundamental, I think the three pillars of learnings from traditional software that can help dramatically reduce this alarming AI project failure rate are really center around value, collaboration, and automation, which I'm going to explore here over the next few slides. Before we do that, I just want to set the stage with kind of what I consider to be the AI or machine learning workflow, and even a little further. So machine learning, we all know, computers learn from data, improve over time. AI is a very ambiguous term, and while I was operating OAG, I really avoided AI because of that ambiguity. It's kind of everybody's got a different definition of it. For me today, I'm kind of using AI. AI includes machine learning, and the difference, one of the key differences between just a machine learning system and a real AI system is that the AI has a closed loop continuous learning capability. So the system knows how to improve itself over time, particularly as more data is generated. We've always had to get the right software in the right place at the right time for these systems to work properly. With AI and machine learning, we also have to get the right data in the right place at the right time, as well as the right models in the right place at the right time. When I started OAG, I knew this was going to be more complex than traditional software. What I way underestimated was that the data, the models, and the software really are degrees of freedom in a high order system. So when they combine geometrically, not linearly. So it's maybe 9x the complexity, not 2 or 3. And I think that's just one of the fundamental roots of underestimating the complexity of these things. But fundamentally, it's a very iterative process with some, when used for the appropriate use cases, some really tremendous advantages over some of the tools that we've had to build software until recently. So this problem, historically, half of traditional software projects fail, and the Project Management Institute, or PMI, is kind of the current tracker. They do an analysis every year, but a lot of these issues go back to the 1960s and a real classic book in software engineering written by Frederick Brooks called The Mythical Man Month. So we've had about 3 generations over 80 years to learn a lot of great lessons about building increasingly complex software. In spite of that, we still have half of those projects failing to deliver the business value on time that was used to rationalize those budgets. Now, maybe only 10 to 20% of those projects aren't making it to production, but they're still, building software is really hard. AI, as I mentioned before, if you think of this degrees of freedom concept, it's much, much more complex. Like virtually everybody underestimates that. It's also much more experimentally intensive. So it's much more iterative. When a human sits down and explicitly programs a computer, that's an iterative process, and the low cost of materials really lends itself to iterative design and iterative development. Machine learning is many orders of magnitude more experimental. I'll get into that a little bit next. Because of all this complexity, because of the experimental intensity, and for some other reasons as well, the cost of these projects winds up being much higher. So planning for success requires really more knowledge up front to be able to accurately estimate these things so that we can appropriately assess these business cases for investment relative to expected returns. So some of these lessons from traditional software, kind of peeling back the onion a little bit here. One of the ways that I think about the objective and the organizations that I've had the opportunity to be a part of, as well as many that I've helped with this, it's to create predictable business value with technology at scale. Much, much easier said than done. That said, there are organizations throughout the world of all shapes and sizes who are doing this consistently. And this is especially more challenging in the digitally non-native businesses. So digitally native businesses, ones that grew up around analyzing data, these are Google, Facebook, Amazon, LinkedIn, Twitter, Instagram. Those are all examples of digitally native businesses. Businesses that have had to, bring technology in to support their line of business, i.e. technology is not inherent to the line of business, generally have struggled with this more. That said, I've seen many traditional businesses of all kinds of shapes and sizes do this extremely well over about 25 years now. Every single one of them start with business objectives and never let that out of sight. They prioritize collaboration, especially with increasingly complex projects. They're highly interdisciplinary. A lot of the projects that can really deliver large value to organizations tend to be complex. It's 2021. A lot of the low-hanging fruit around technology has already been harvested, and the collaboration is just critical. And then the investment in top talent. And this is a cultural issue that varies tremendously among different industries, especially with the more complex technology. The value of the senior resources, the efficiency with which they can create meaningful solutions is much, much higher in many cases than with more junior folks. On the tactical side, really seeing that, we learned this at OAG, and I'm really encouraging folks to do this, as treat AI as a tool in the broader software engineering toolkit, and not AI as some completely new thing that we have to figure out how to do from scratch. Similarly, deployment automation is the foundation of successful software engineering at scale. It is wildly critical to be successful with AI. And to not do this is literally to try and build a house without pouring a foundation first. And then lastly is this optimizing for experimental cycle time, planning for that up front, which is a very easy thing to overlook. So peeling back again a little bit more on the strategy side, business objectives. So fundamentally, starting with how do we, CEO, board, going to say, hey, we need to reduce costs in this part of the business. We need to increase revenue in these other parts of the business. And aligning with top line initiatives is critical for technology success. Similarly, establishing metrics to measure the progress and the results as we move through these projects and deliver them, and being disciplined about that, critical. And then we use the technology to deliver that value. Kind of the opposite of this, which we see a lot, is, hey, we need to do AI, we need to do something with machine learning, let's start doing some pilots, let's bring some vendors in. And those science projects are interesting, people learn things, but they are academic in scope. They don't ultimately deliver business value. And while the education is valuable, is helpful to the organizations, the goal is to deliver as much value with the technology as quickly as we can. The second is collaboration here. So complementary adoption. There's a natural tendency in many organizations. Some of this is cultural, where we really think inherently, or just kind of automatically by default, we think of business value as when we replace something that we're currently paying for. So it's kind of like we replace the old way with the new way. We isolate that cost and then the contribution. And that's often a reasonable way to think about things. With AI and machine learning, we're seeing much more success. And we've seen this with some traditional software as well, where we bring the new way in addition to the old way. It's another vote in the room. And if we had, two ways of evaluating a project before we committed capital to it before, and now we have a third, well, when all three technologies or all three approaches align, we have even greater confidence. We've reduced the risk of that capital deployment. Similarly, if we have one dissenting vote, which there's now more opportunity for because we're looking at the problem in a more diverse way, there is the opportunity to reassess that commitment before we deploy the capital. So, that's a lesson from traditional software that I think is absolutely huge for AI. And it's important for organizations to be aligned on that at the highest levels before project starts, before capital is invested. It's a big one. And then feature engineering is also just, we've seen over and over again, not only in the energy space, but more broadly, is just it's a critical capability. So fundamentally, features are the inputs to ML models. Some of them are raw columns of data, others are engineered. We apply human algorithms. Sometimes it's simple transformations, like applying a deterministic mathematical function, like a sine or a tangent or some kind of normalizing function. Some of them get, even more involved and, will incorporate, more traditional physics and whatnot to raise the value of a feature or raise the value of the data and ultimately create a more accurate, more useful model. So the third piece is talent, and organizations that know the cost, and leaders who know the cost of everything and the value of nothing, are falling on their faces left and right with AI, especially in organizations or in industries that historically have not prioritized digital technology. And energy is has been one of those industries. It's not to say that every company, every team, every culture is afflicted by that, but overall, you hear more energy companies talking about, digital is just as important as traditional, but then you look at how they invest in talent, and they have this really senior, huge investment in the traditional talent, and they invest in a very different, much lighter weight way in digital talent, and then they don't get the results from digital and blame the technology. So focusing on value, especially the top senior technical leaders and engineers, to generate momentum in these projects, and get started with those first critical production adoptions. So a couple points on tactics now, and I think I'm doing okay on time. So I was guilty of this. I've seen, I think, a lot of folks who have software engineering backgrounds were so overwhelmed by the complexity of AI that we approached it differently. And then we started engaging with customers who wanted to do the absolute minimum investment possible to experiment with this technology before committing to it. They knew that at some point in the future that this is going to become a necessity. It's not a necessity yet, and they wanted to dip a toe in. And that approach, especially in a lot of digitally non-native businesses who've been experimenting with AI and machine learning over the past 10 years, has resulted in just tremendous project failure. And it creates quite a paradox, because when we fail by doing it, by dipping a toe, there's a lot of resistance to making a bigger commitment. I'd say, similarly, really need to look at, like, if you want the same results that everyone else is getting, which aren't very good, do it the same way as everyone else. Conversely, right, do it the same way as everyone else, get the same results. So I'm really trying to look at this problem from the standpoint, we are looking at this problem from the standpoint of what are some concrete, proven, tangible things that we can do differently to help create better, more consistent results here. So AI on a standalone basis, the models specifically, they need software to connect with humans, to connect with business, to be able to ask questions of the models, whether they're individual questions or larger scale simulations where we ask a whole bunch of questions at once. But because of the inherent kind of black box nature of this technology, when we use it for high consequence, capitally intensive decisions, almost always we need transparency into the machine learning. What data did we use? How did we configure it? What data didn't we use? How did we configure these features? How did we configure the models? And a standard way, a standard workflow for evaluating the accuracy, the efficacy, ultimately the usefulness of the models, right? All models are wrong, some are useful. We have to be, if we want to scale, we have to be consistent about how we determine usefulness and how we compare one model to another to measure improvement. So there's a lot of software around all that. Again, there are parts of that software that overall system is much more complex. So really encouraging folks and seeing a lot more success. We had a lot more success at OAG when we shifted our mindset to we are doing enterprise software and AI is a tool and machine learning are tools in this toolbox, there are times it is much simpler for a human to tell a computer exactly what to do. AI and machine learning are appropriate when configuring the computer to be able to learn from data results in more accurate business logic. So moving from something very explicit to something more statistically centric in nature can result in much better results, particularly when there is a built-in continuous improvement mechanism within that ability to learn from data. So AI is not always the right tool. It is the wrong tool if a simpler solution works. But thinking of this as a way to automate implementing some of the business logic within these systems, again, is aligning with more project success. So deployment automation, this is a big topic. I'm really only going to scratch the surface of here. The goal is before we start deploying capital, before we start evaluating vendors, because we only want to build ourselves what we absolutely have to build. There's no way to buy it. If there's a way to buy it, it's virtually always cheaper. So getting really good at evaluating which tools, because no vendor has a tool that's great for every problem yet. I think it's gonna be a long time before we see anything like that. Virtually every vendor has technology that's good for some problems. So getting really good at evaluating different tools for a specific problem is an incredibly powerful, incredibly valuable capability. We also see that a lot of without this, without an interface to interact with the model, without the software to interact with the models, and without the models being delivered in a standard way that aligns with essentially template-driven software, regardless of whether the model was programmed in-house, whether consultants worked with an in-house team to do it, whether it's an external vendor's model, it is possible to deploy all these models in a way where they can all talk to each other and they all speak the same language. That does not happen by itself. So when an organization defines this, essentially these contracts, and then requires that their employees, their contractors, and their vendors all deliver in a way consistent with this defined contract, they wind up with much more valuable deliverables from their vendors that in some cases might not even be of maximum value to the current problem, but can be leveraged to as part of other solutions in the future. The alternative to this, and what we see all the time in pilots, is that without this, models get delivered as PowerPoint presentations in Excel. They're not executable, they're static, and they're really they're very constrained with their ability to deliver value to an organization, particularly at scale, until this can be done. Coming back, we've got our workflow again, experimental cycle time. So when humans are explicitly telling computers what to do, that's still an iterative process, but it's basically like we're telling the computer what to do. There is so much more complexity when we're configuring how the computer can learn from data and program itself, that just requires, it's just a lot more experimental. So as a result, really optimizing for experimental cycle time, by default, organizations can generate, say one model a day or one model every 48 hours. When with the right software that's properly optimized for this, organizations can evaluate tens, even hundreds of models in minutes. They have a huge advantage over the organizations that are moving really slow. And if you don't have this infrastructure in place before you start the pilots, it's really hamstringing the pilots and becomes kind of this vicious, negatively reinforcing cycle. So quick case study, and then just about to wrap this up. So we worked with a large independent oil and gas company, and they wanted to improve the accuracy of their pre-drill estimates for their infill child wells in the Permian. We delivered to them software and models that the asset team used in addition to their decline curve analysis and their RTA analysis. So when we started, they already had 2 votes in the room. By adding this capability, we got a third, and especially with their tightly spaced wells, that they were infilling years after they had drilled the original wells in those DSUs. The machine learning technique was able to understand the spacing and the impacts of depletion over time on oil, gas, and water production much more accurately than the other two, the traditional decline curve and RTA analysis. So having these three approaches all working in parallel resulted in some really great results for this company, 5 times faster and at 1/10 of the cost of these guys, building all of this themselves internally. So just a quick example of where the or how the application of this these strategy and tactics have worked well for some oil companies, and then quick bio on me, which was just for completeness here. And that's all I've got. So thank you guys. And Allison, I will turn this back over to you.
Thank you, Luther. I really appreciate it. I think there were lots of us on this call that wanted to kind of say, can I get an amen for a lot of the points that you made? So that was wonderful. Thank you. We will take about a 5-minute bio break. It's about 10:30. So we are just about 2 or 3 minutes ahead of schedule here. So again, we'll do a quick bio break, grab a cup of coffee, and we will be back where Chris and Raji will join Luther. And we will open everything up to our attendees for discussion and Q&A. All right, it's about 10:35. Let's roll with the panel. We've gotten to know Luther just a little bit. So now, Chris, Raji, if you two wouldn't mind, Raji, please, you go ahead and go first. If you two wouldn't mind just introducing yourselves, tell us a little bit about you guys and your role, and then we will open it up to the audience to begin discussion.
Thank you, Allison. Luther, what a great presentation. Thank you for all that information. I'm Rashi Gajula, been with Pioneer for about 10 and a half years. Pioneer is an independent oil and gas company operating in the Permian. My role has evolved over the years, but with a strong technology background. And for a little bit gone into the business and really understand the process and all the automation that we were trying to build around at Pioneer. Currently, my portfolio is about automation. So this hits home, digital transformation, automation, and living and breathing some of the projects that failed that you talked about and some of the projects that we're seeing success with. That is the nature of the business, is that we keep experimenting to get better.
Thank you, Raji. Chris?
Yeah, my name is Chris Kettner. I'm the Vice President of Product Development at a company called Phase 2 here in Oklahoma City. Phase 2 is a software consultancy firm. We offer both turnkey product teams for large organizations that want to advance their software offerings, whether that's internally or externally as customer-facing solutions. We also do a lot of collaboration with large organizations to just further their technology capabilities via consulting, custom development, and digital transformation operations and assistance and all that kind of stuff. So my role here is sort of helping facilitate all the things I just said, kind of leading engineering teams, talking to our customers and the organization's sort of executive layers, and setting the stage and consulting them on how to successfully execute a large project like that.
Thank you all. All right, who is first? Any takers to open up this dialogue and discussion with questions? Well, they're going to be quiet this morning, huh? Okay. Let's start with biggest learned lesson from a failed project. Each of you go. Maybe we'll work the other way on my screen. Chris, can you tell us a story? So Chris has a lot of experience from outside the industry. So it will be interesting to hear and learn some of those lessons to see if any of those resonate here on this call.
Yeah, I think Luther did a good job of covering a lot of the key points on how you see things fail. It really always comes back to people, and specifically, generally leadership roles and their inability to change or to get too focused on a specific goal and not appropriately back into the actual problem they're trying to solve. It's easy for somebody to just see a solution, or maybe a competitor did it, or they saw something online or wherever that, oh, this company is using this tool for this thing. Well, we need to do that. And that's not always the case. And if they don't take the time to, kind of like Luther said with some of the DevOps methodology, it also tracks just from a business perspective, building that appropriate foundation, and both from a leadership perspective, a team perspective, and really analyzing the problem they need to solve. What can they, where is the opportunity for improvement within the organization, and start there instead of starting at the solution and backing in. That tends to be one of the most common things I've seen.
Yeah, well said, Chris. I think, a couple of thoughts that floated in my mind while you were talking about it. Leadership, their commitment to a project. And if you peel that a little bit further, why does that change? Is it because the nature of AI, it's complex? Yes, but at the core of it, it's so disruptive that there is a fear factor. It's that the black box nature of it. Is we've traditionally done it all the way, and we've perfected it, and we know when we can visualize a change, it's easier to accept it. But with AI and the cyclical teaching itself, or machine learning, which makes you smarter, and not through learning step change, but that transformational leap that you go through, it is very difficult for a traditional leader to get their hands on it. So it is definitely a people problem, of course, but I think it is also the magnitude, and the other point there is the change that's coming at it. It's not a bite-sized change. It is so much change, so fast. The velocity of it is compounding that problem of being able to adjust and be flexible and agile with it.
Thanks. So Allison, this is a great question, and Chris and Rashi so much agree with your guys' perspectives. This is a fun panel. Allison, if I had to put it simply, the biggest lesson I've learned from failed projects is not to work with spineless CEOs. For decades, the C-suite has been pushing technology decisions down in the organization, and really gotten into this established pattern of abdicating responsibility for technology success. And AI, it's just too complex, and it's complex not only at the technology level. We didn't used to talk about ethical software development.
Mm-hmm.
We didn't sit around and worry about and watch movies about software taking over the world. So there's just a lot more. There's a lot more fear. There's it's fear of people's jobs. What does my role look like? That has to be managed by a strong leader to keep the balance of personal objectives and corporate objectives appropriate for these projects to be effective. You don't see a lot of people getting like too much into the company, but when people get scared, when people get uncomfortable, current environment, there's so much uncertainty to begin with, it only amplifies this. But the more they start fearing for their own jobs and the uncertainty about what their future role may be, the less likely these projects are to succeed. And that is a responsibility of the CEO.
Geez, Luther, you don't pull any punches. I like it. No,
it's nice not to be in a CEO role after 8 years in the hot seat. So
there you go. Yeah, there you go. No, we've definitely seen that, where there's just this paralysis because of a bad experience, and now they just don't. They just they do nothing. They will not do anything, and it's like, hey, it's been a couple years now. It's time to put your big kid pants on and really drive this technology focus, if that's really what you want to do. It's time. So we did have a great question coming from kind of that CEO leadership level. Now Joe is going to take us all the way out to the field, where the origin and the source of all of the learnings and the data lies here in our industry, at least. Jim, can you give Joe the mic and kind of let him talk through his question?
He has indicated that he's got a bad internet connection. And in fact, he actually is in the field right now. So
oh, well, heck, okay.
It's not cooperating. So just go ahead and read it off.
Awesome. Okay, so you guys can probably all see this. So Joe asked, is it a struggle to get accurate field data on these projects? I will do my best to be quiet here.
I can mute you, Allison, if you need me to. So just
I'll mute myself. I can do it.
I'll take a first stab at it. So is it a struggle to get accurate data? So the key word there is accurate. What defines accuracy, and how good is good enough? And with IoT and sensors and gadgets that have traditionally all been long, we know telemetry is out there in the field. We're collecting oodles and oodles of data, but how do you take that data and make that meaningful information? And that's where it becomes the challenge. And it is becoming lesser of a hurdle. I think many of our companies have invested a lot of hours and a lot of capital in trying to collect that data, because I think that was one of the first, dial back 5 years, one of the first barriers for AI was, okay, we have fragmented data. I can give you a quarter of an answer, but I need a whole bandwidth. I need the whole sphere to be able to make that prediction, which is more accurate. So to combat that, I think most of our industries went in and said, let's go collect data, collect data. And now we have more or less a lot of projects that bring in machine data, human data, and data lakes have appeared, data oceans are almost here. How do we make information of it is what the question has become more recently.
Yeah, I think that's well said. And it really points back to, it's not just about getting accurate data, it's about getting, like you said, getting accurate and usable data, clean data. And if you just have a ton of accurate data, but it's all in different formats, or it's not coming across the right way, or it just ends up in some spreadsheet or database and multiple models, and then you have this big issue of getting the data out and making it meaningful and getting it aggregated in good ways, then that doesn't, you've only solved part of the problem. And I think that's, like you said, kind of where everybody is right now.
I guess a follow-up then to that is not just getting the accurate data, but then actually using it.
Mm-hmm.
Oftentimes you hear the analogy of drinking out of a fire hose, that people use, that there's so much data coming in. So I guess transforming it into a usable format from which informed decisions can then be made out of it is kind of the next challenge as well, isn't it?
Yeah, the informed decisions, I think the trust of it is huge, though, is what, on top of that is saying, okay, now I see a trend and I've done all of the due diligence and the work, and I believe the data, and I have this trend.
Mm-hmm.
Seems like this big hump to say, okay, I'm now going to go place a bet on this trend, whether that's a performance in the field or some type of commercial bet for pricing. There's that step that you kind of have to jump into and say, okay, I am going to trust this data because I've done all the work to do it, and I believe it now. So
that's excellent. I mean, Allison, the question there also becomes, whose data do you trust? Do you trust the data that you have, or do you trust the data that your vendors are going to give to you, suppliers and all of that? And how does, Chris, what you're saying, okay, well, how does all of that merge together to be that one data point or information?
So I agree with everything that's been said. And one thing that I'll add, an additional struggle, is that most of the best data is proprietary and it's very expensive, right? So if we invest $10 million on a shale well, really the only thing we're guaranteed is data. That data has value, but the companies don't know how valuable it is yet. So there's really very limited ways to access someone else's proprietary data. I think there's a tremendous opportunity for the industry to monetize the data. But again, that requires senior leadership to invest in education to understand that problem better, as a prerequisite for being able to sponsor a successful top line initiative to make that happen. When that does, I think it's going to be transformational. And one other kind of related piece on this is that historically, folks have shared data on ventures. And in fact, one of the reasons for taking like minority interest, non-operated interest in wells was actually to acquire data that could then be leveraged for your local field development. Going forward, folks are going to be collaborating with data and technology in a much greater capacity, which just reinforces that need for having all the infrastructure that readily lends itself to collaboration around that.
Luther, you made a good point about, hey, we drill a well and we have data from this one well, and yes, it's valuable, but how valuable do we think it is? Or maybe we discount the value of the data from that one well, and making sure that every little piece of data is right. I've always thought about kind of data quality, data thoroughness, data at scale. It's almost like compound interest. no one cares if you save $100 last month or $5 last month, whatever, or I hand you a penny. But if I hand you a penny, and that's indicative of one little teeny tiny, what seems like an insignificant data point, and I do that a million times, well, now you're paying attention, and it just, you have to kind of see that investing in data and data quality in this one component or this one little piece and what seems like minutia in the grand scheme of things really, really does add up. And that is one of the big challenges, I think, with trying to understand that data quality, is Raji's talked about. Hey, so we've got some good questions coming in. Taylor, Jim, can you give Taylor the mic? And then we've got a couple of questions from Kevin McLeod. So we'll kind of go from Taylor to Kevin, and then we've got some other good ones coming back in from Joe and James.
Yeah, good morning.
Hi, Taylor.
My question was just on advice for selling management on the value of AI and process automation, especially if they kind of think that whatever they're doing right now is good enough. So how do you, I guess, try to show them the value, even though there's commercial and technological risk involved, and where do we go from there?
So Taylor, I'll take that first. To say that the current methods are good enough in an environment where the industry is suffering so badly because the cost of capital has skyrocketed is a ridiculous proposition. Management teams to succeed in especially U.S. independents need lower cost of capital, and this technology's ability to create more transparency, I believe, can make a major contribution to that strategic imperative.
Anyone else want to contribute to how to sell AI to a CEO?
Yeah, I deal with this a lot in my role here, and I'm not going to talk specifically about AI as a tool, but technology as a whole. And back to some of the stuff that Luther said earlier, it is a kind of a game of fear and trust. And technology overall, especially at the scale, is still fairly new as far as sort of the history of industry goes. And it's still a new concept, and people don't trust technology yet. People don't trust technology to always solve their problems. And the easiest way you can get to, and it's not easy, let's be clear, but the easiest way you can get to selling the value of something like AI or technical solutions or process automation is by the people that are responsible for it building trust with that leadership and finding short-term value and finding quick wins and identifying problems and laying out kind of a plan in order to start seeing small bits of success. Okay, easing them into it. This thing can work here. This can save me some money here or help my team here. And then you kind of get them to the goalposts later on. You don't just jump in with, hey, we're going to just change everything all at once. And that's been said a couple of times already. And that really speaks to the challenges we have as technical consultants and as technical leaders, is easing people into this, forming trust first as people, then applying that trust to the technology and the technical solutions.
Awesome, thank you all. Yeah, one of the comments, Raji, that you made earlier was about how the change feels so big and can feel just massive and overwhelming. And it's like, well, this is what you guys do every day, and we do want to impact that in a positive way. I know, you don't go just lay a foundation without having the house planned out and a vision of what that house is going to look like. But you also don't want to overwhelm management with this whole house and the plumbing and all of the things that you have to go into building that. And so that is certainly a balance. How do you deliver on that? I've kind of a follow-up question, maybe to Chris. How do you guys actually deliver on that? Is there any better methodology than others that you've seen allow an elephant to absorb change rather than kind of what Raji mentioned or alluded to, where it's just so overwhelming they end up doing nothing?
Again, it really comes back to approach and one bite at a time. And it's really easy for us to, as people that do this for a living and are very passionate about it, it's really easy to fall into this thing where you can immediately see 10 steps down the road, and you know where the right place is to go, and you know where they need to end up. And if you just come right out of the gate with all of that, it is incredibly overwhelming. And all they hear is dollars, 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 and struggle, and this massive change to organization that they might not really be ready for. And a lot of people don't understand that the digital transformation and incorporating process automation and things like AI, machine learning, it is so much of an operational change in addition to just plugging tools in. It's not just plugging tools in, right? It is fundamental changes to how the organization's going to react to things and how they're going to operate, and that's from leadership all the way down. And that we've touched on this a couple of times, that is incredibly overwhelming. So taking that one bite at a time and showing them, here's how we can here's the first phase of this, or an MVP, or some ways that we can kind of do this a little bit at a time, department by department, or vertical slice by vertical slice, and then start easing them in again to that idea of whole hog change. It just takes a long time to get there, and you just can't come out of the gate with the final product and pitching them the final product is just going to scare them and intimidate them.
Thank you.
Yeah, Chris, one thing I'll add to that also is that, in many industries, balance sheet centric business cases are sufficient. We look at the impact of the cost savings, the increased revenue on the total net revenue picture, or EBITDA, or whatever metric is primarily in play there. Energy, and specifically oil companies, are a little bit different in as much as there's also this reserves-based lending concept, which is absolutely critical to operational capital. And there are often trade-offs with some of this. Taking the reserves-based lending picture into account with technology adoption is critical. You can optimize your wells to generate more free cash per well, but if those are smaller wells, that can actually wind up having a significant impact on revising all the reserves down, which then impacts the reserve-based lending, which, especially in the current low interest rate environment that we've been in kind of through the whole shale boom, is a really big deal that not enough organizations are talking about. So the point is to look at the comprehensive value picture, and that's really board level, and it requires board level and C-suite alignment in the project planning phases.
Thank you all. So Jim, would you mind throwing the mic over to Kevin McClard? He's got a couple of questions that he's asked in the Q&A, so we'll give him the floor. Kevin, welcome.
Yeah, okay. I've just had a couple questions. One of them being, what are your recommendations for developers who are unfamiliar with AI to educate themselves in the nuts and bolts which are necessary to implement AI? I personally have taken a course at Rice University and somewhat versed in it all, but it's a very long road in order to get educated on this. If you guys have any good ideas on how to help other developers.
Hire a mentor or a team of mentors, depending on the size of the team. Work closely with them until your team's up to speed.
And I'll add one small thing. Make sure you have developers or engineers that want to learn that and that have the capability to learn that. There are a lot of people in the development community that want to just do one thing and want to do one thing well, or complacent. Starting with a true engineering team that has the passion and the desire and the capabilities to learn new technology, to embrace new technology, and always continue to grow their skill sets is where you have to start. Otherwise, you're just going to be trying to cram information into a vessel that doesn't want to take it, and it's not going to go well.
Yeah, I know that problem. The other thing I had is more just a discussion. You can't really change it, but do you think that perhaps the term AI is a misnomer and that it might be better to try and talk in terms of it as advanced data evaluation? You know, clearly computers don't think anything at all like a human being. And I think a lot of people are just afraid of computers being more intelligent than they are. And it's really, AI is just a very advanced tool that we use to make better decisions for ourselves. And if, how you approach that when you're talking to people about AI in your discussions.
So Kevin, I'll share my thoughts. You know, I mentioned earlier during my presentation, for years I avoided AI, and it's a tricky one because
Yeah, I'm sorry, I missed the first part of your presentation.
No problem at all. I was just, you know, just confirming agreement with this. So I've struggled with this. What I do, the fundamental thing that I do is when I use the term AI in any presentation or conversation, I share my definition of it. And in interactive conversations, I ask people what their definitions and understanding are. So we create a common language around an otherwise very ambiguous term. That's helped me the most.
Okay.
I will add, Kevin, I think you bring up a good point. The words artificial intelligence, machine learning, smart contracts, they do instill that fear of, okay, well, we're allowing a set of machines to take over the world. And maybe we could have been a little bit more, as technologists, a little bit more cognizant of how the perception of these names would be with the company. And I personally, one of the, you know, how do you sell AI to your senior leaders? You know, I kind of tend to take a spin on to say that I'm not selling the technology. I'm really selling the problem that we're solving. So I'm selling an issue. So to kind of take that narrative out of the picture is that, hey, it doesn't matter what technology, it is the problem that we know and the pain that we have in our processes that, or the efficiency we can add to a current situation that can be more valuable and not focus on the technology as such.
Okay, well, thank you for your perspectives.
Yeah, thanks, Kevin, for the questions. Those are good ones. James Lakings, I hope I pronounced your last name correctly. James, you've got a question here. I think Jim can give you the floor.
Good morning. Thanks for the panel discussion. I just have a general comment. Having worked with a lot of data engineering problems, feature engineering sort of things, and trying to solve problems, but not using AI per se. Is there a hurdle? Is there a perception within the oil and gas industry or other industries that AI is truly objective? That is, there's obviously a fair amount of, in the workflow, data cleaning has to be done. You can think of lots of engineered features that could be employed. And I'm just curious, is that, how does AI, or what is the message to the end user or the people who receive the results and the visualizations, that this is an objective outcome as opposed to something that may be biased by the team or the individuals within the team through the collaborative process that could be introduced either unwittingly or I don't want to say deliberately, but with in terms of the results. That is there perception, just to repeat my question, is there perception of AI that is truly objective?
So James, hey, it's Luther. I guess I'll take the first stab at that. So I don't really view AI as purely objective, or deterministic. There are some modeling approaches that can be closer to it than others. There are, if you really get down into the nitty gritty of it, you can take the same data. It is possible for some models to essentially, take the same data and wind up with slightly different models. And this again, but the solution to this really comes back to the business value and aligning with the top line initiative and staying in alignment with the top line initiatives of the organization. If you stay focused on outcomes, then it becomes more difficult to get hung up in the minutia and the what ifs along the way. Every model is wrong. Some models are useful. Some models that are programmed, explicitly by humans, pure physics based, let's say, they're all wrong. Some are useful. Same thing is true of ML. It's possible to introduce all kinds of bias throughout these, especially in the data cleaning and the feature engineering, as you mentioned. But those biases are also where the subject matter expertise comes in and creates the opportunities, especially with smaller data sets. And like the oil and gas industry has a lot of data, but like Google does 3.5 billion searches a day. We have, maybe like a big company like Pioneer, and I don't know where you guys currently are, but maybe they're drilling 200 wells this year, probably not even that many. Because of the capital intensity, because of the complexity, the volumes are so much lower. So for machine learning to be additive in this space, we're working with these much smaller data sets. We need to combine the human expertise, the subject matter expertise, which gets introduced through the feature engineering into the ML modeling. So the bias, if done properly, is an advantage if we're aligned with delivering the value and we have a standard method for measuring the value of each iteration of each model.
Yeah, it's important to remember that it's easy to overshoot what AI can mean and what machine learning can mean, especially right now. The point of this is not to replace people with technology. It's to let computers do what computers are good at doing, which is repetitive tasks and ingesting data and applying logic to data. And you want to pair that with subject matter experts and human mind interpretation and analysis. And that's where the sweet spot is. It's not just replacing human beings with computers.
Yeah, so the bias is the person coding, not necessarily the machine learning, right? So I think that's what Luther was trying to say, is that for all we know, the models that exist out of AI also have the same biases because they're still developed and engineered by the same people. Maybe the differentiation here is that now you're definitely working with the same people that have the same biases to create the model, but you're adding an extra layer of abstraction from that bias by the continuous experimentation and the adoption and the more intelligent that they can become. So in some ways, I would even say that AI reduces the bias and not necessarily increase it any more than we already have in our existing models.
Yeah, that's a great point. And in some cases, we've even seen that AI can have different biases, which results in multiple models using different technology, different approaches that are all useful. And in that way, they're maximally complementary.
Right.
Awesome. Thanks, James. We've got a question from Michael Bird. So Jim, if you'll give Michael Bird the mic, and then Joe asked a question about politics, which I think will be a good one. So Michael, you are on, and then we'll come over to Joe's question.
Sorry, can you hear me?
There we go.
There you go.
Michael.
Yeah, sorry, my world's a little noisy here. I apologize. Yeah, just to repeat my question, I'm wondering, essentially, I know a lot of AI models do the best when they're trained around a few variables, like few moving parts to make sure that you're trying to optimize, so to speak. So generally, I'm wondering, what can companies or data analysts really do to ensure like valid comparisons, apples to apples type comparisons, where a multitude of real world factors could apply, like the hand on location showed up late, or a manager made a poor decision, or a tool was not properly set up ahead of time, like just the fewest factors possible. How do you include real life applications into a data model like that? that make sense?
That makes sense.
Yeah.
I think it's a really hard question.
Yeah, Michael, that's a tricky one, and I'd say really there is something inherent, and I'm guilty of this as well, about, when I hear traditional software, I expect it to be highly fallible, but when I hear AI, I start expecting it to be perfect. And I get down there's this like really tempting rabbit hole about like, we can't do AI if it's not going to be perfect. What matters is improvement, its usefulness. And that again is tied to the outcomes related to delivering business value. So if we can get strict about a baseline, and then we compare, our multiple complementary approaches for estimating project outcomes to those established baselines, and especially if we can do that, use software to facilitate the governance of enforcing that structure, and then also use that software to expedite the cycle time so we can do it really quickly, then it becomes scalable and it becomes applicable. But this is again, and then there's the CEO who's got to lead the charge that there is no perfect AI. And that is not an inconsequential challenge to lead. Great question.
Thank you. Good answer.
There was your question, Michael, reminds me of a comment that a gentleman from Baker Hughes spoke at a drilling automation conference a couple of years ago, and he lamented that it was really hard to capture the intent of a human. That was one of the things that they were struggling with, is this organic relationship between a human working within a system helps them do their job better or whatever. But then there's also this intent of what they're trying to do versus a system knowing, okay, well, what actually was the consequence of that? What happened leading up, and was that consequence, was that a good outcome or a bad outcome? So that's a really challenging one to answer. And one of the things I hear from a lot of, just as a theme here, is a lot of discipline around some of this. I know we see it quite a bit where companies have this, we want to do something with data, AI, like we got all this data, let's go do something with it. And it says, well, okay, yes, but it's one of those things that companies have to take those really unsexy, very disciplined steps to to do it and do it well and do it right. And that's also coming back to kind of what the point Luther keeps driving home is, and really all of you keep driving home, is the leadership has to drive that discipline and understand that there are steps you have to take and you really just can't circumvent them. You might be able to accelerate them with good technology and good infrastructure and a nice budget, but I've never seen where you can circumvent these. So yeah, very good question, Michael. And any other comments there? Chris, Roger, Luther?
Add one other thing really quick, Michael. In some conversations, kind of trying to take like deliberately taking some of the sex appeal out of AI has been helpful as well. So if we think as AI as a tool in the software engineering toolkit, essentially how we're using it is to program conditional logic, right? Software is full of conditional logic. A human can program if then else up to a certain threshold of complexity. For some use cases, we can get more accurate if then else logic by using a machine learning, more of a statistically centric approach, because the computer can program much more complex if then else logic itself, which is essentially what most of these machine learning models are these days, are just these big complex decision trees that are more complex than a human could ever program. So it's like a really tactical level. Machine learning is an alternative tool for programming business logic into software. And at that level, it's not nearly as intimidating or as obtuse. Again, particularly if you have the right automation infrastructure to support the validation.
Yeah, thanks, Luther. That infrastructure is definitely key. Michael, any other follow-up questions to this discussion?
No, ma'am. In fact, I think actually the question prior to mine, when you answered reference some expertise, actually kind of applies in this case as well. From personal experience, I just would like to add that where you do have outliers, and you should always pretty much be looking for outliers in your data, right? Frequently, those are the cases where these types of situations might apply. So if you're doing an AI training model and you look at that weird outlier and it looks one-off, well, are you capturing the reason, even if it's not in your model, why that is happening? Because ultimately there should and will be a reason. And so long as you refer to expertise and you have a place to capture it, even if it's not in the model, you can explain that part of the data pretty much every time realistically. So that's
Yep.
another answer.
That's
Mike,
a good point.
Those
Yeah.
reasons. Oh, I'm sorry,
Go
Chris,
ahead.
go ahead.
No, you go ahead.
All right. So, Michael, when those reasons are tied to really meaningful, painful mistakes in the business in the past that we can prove could have been avoided if we had used this technology to help inform that, planning process. And the classic one is we way overestimated the production of a tightly spaced well in a drilling unit that had, its first well drilled multiple years before those child or those infill wells was drilled. And every company's done this. The whole industry cost, I think that's a big driver of the cost of capital to the US industry, especially having skyrocketed, was way overestimating those infill wells. So there's examples in every data set of it. Culturally, people don't want to talk about it. They want to move on. There's all that stuff. But if from the leadership level, we put the elephant in the room front and center, say, this is the problem we're going to address. There's tens of millions, if not hundreds of millions of value to the organization if we can improve in the planning process for this type of project. That's the kind of leadership and culture in which I see the 15% really excelling and succeeding at this consistently.
Yeah, and that example, oh, you're fine, thank you. That was great. And the sort of example that Mr. Bird was talking about also, it just drives home the importance of the training aspect and the ramp up into these kinds of paradigms and solutions, and that you need people that understand that data and understand what those outliers truly mean, so that you can, like Luther said, build those decision trees or help the machine build those decision trees based on expertise and not just humans not knowing what the data are and just plugging numbers into a computer. It's not going to work. You're not going to get good training. You're not going to get good output.
Yeah, the wonderful question about outliers, or we look at it and I've heard many times, we look at it and we just, we take out, if it's bad data, we take it out, and you think, well, I mean, is it bad data? Is it an outlier? Is it not? The devil is in the details with those things. All right, Michael, anything else? Thank you.
No, ma'am. Hey, thanks, guys. Good answers. I appreciate it.
Okay, well, let's put a little gasoline on this fire. We've got about 12 more minutes. Courtesy of our buddy Joe. How do you handle the politics when the models indicate personnel is the problem, i.e. field team A has a 40% higher failure rate than field team B? Go.
All right, I don't mind taking a first shot at this one, and it's collaboration. If you have an opportunity in any business from one, well, first of all, don't assume that one team is better than the other. In an environment that's this massively high order system like extracting subsurface resources, there are so many unknowns and so many reasons other than team A being better than team B. So if you've got one team getting different results from another, I'd say the first thing I do is bring them together and let them together try and figure out why. And I don't know, every time I've seen organizations commit to that, both teams wind up being better than either of them would have been had they stayed kind of competing in isolation, making incorrect assumptions about why.
In drilling, don't we just say it's the mud system that's the problem, like formation issues?
I hear the geologists getting blamed a lot too, Alice.
The rig crew. Raji, any thoughts on this? This probably hits home for Pioneer to a certain extent.
Absolutely, right? I mean, we have all disciplines in the room trying to, put the respect coat on, but at the same time get their claws in and try to show, why they're better than the other. So I think that it is a very healthy way of bringing out the best, and to be able to have, there's not one team absolutely failing, but I think there's more to learn from the team that did not do as well as team A, because maybe there's some parameters that they were looking at it more than what the winning team was. So I think it really it helps hone that process of understanding what is the recipe for success. So I think it's important to have both. It's critical to have both in some ways. And I think the winning team, at least something that in our culture we try to do is it's important to fail before you can succeed, and that's kind of not something that is penalized in organizations, but looked upon as a stepping stone towards a bigger answer.
Those were really, really good. I thought this would be contentious. Those were great answers. And this is about people. This really does come down to people. We see it quite a bit where there's some level of job fear, and the conversation always has to be that our goal is to give you more. It's to give you more cycles so that we can really harness the brain power that you have, instead of kind of what Chris talked about all the time, where it's computers should do repetitive tasks and automating logic and things like that. Humans really don't need to be involved, but that's a sticky conversation to have, but it's an important one.
So now, Allison, I'll throw one other thing in here that if there is a team in an organization, oil and gas or other, that's not cutting it, the leadership in that organization has a responsibility to themselves, everyone else who works there, and all of the investors, to replace those people who aren't cutting it with people who can. And it's not a comfortable conversation, but it's the reality of the world we live in. And Jack Welch made some points, one of many managers who's made points about the people who benefit from that the most are the people who are removed from the roles in which they're failing, because that creates an opportunity for them to move into another role in which they can succeed.
Yeah, that's definitely true. Raji?
I think that's a great thing. Having played the gym at Pioneer, I know it's important to go through different organizations and teams. With all the changes that we've been having, I had 4 different managers last year, and in the process of which I had 3 different teams that we would always just get together. We're getting into our groove and got a rhythm going, and hey, no, now I have a different team, a different home to make. So you're right. I mean, it's somewhat about gymming around and trying to find out where's your sweet spot. But also in the process, I think at every step of the way, the change helped me become better, and pick up more lessons, more people, more relationships. And that's an important aspect of it, of trying to do different things with different teams, and maybe creating somewhat of a matrix team. And a couple of our projects that we initiate, we try to never have all the experts that know it all. You want to have somebody in that team that knows nothing about it, is the outsider, and can provide a perspective which none of the other folks have ever done. So the team dynamics is important, and you need to have different roles and different hats that you have to wear all across.
Any other comments? Thank you both. That was awesome. So we've got about 6 minutes. Are there any other questions from the audience that you guys would like to ask? Any open comments? Please join in.
Allison, while we're waiting for that, this conversation took me back several years to I was in Colombia I was teaching a school on multilaterals, complex drainage architectures to a number of South American oil companies. And there was one guy who's an older drilling superintendent, drilling manager actually, who at the time, and this would have been the early 2000s, was absolutely convinced that it was physically impossible to drill more than 500 feet horizontally. And in the same room was the folks with Petroswada in Venezuela, who were drilling laterals with a total exposure of over 30,000 feet. So you have on one hand, somebody who's convinced that it's impossible. On the other hand, you have somebody who has done multiples past that. And I think that that's a good directional drilling illustration of some of the challenges that we face with this type of approach. There's the misnomer of what artificial intelligence is it's not iRobot coming in and taking over your household. But the appreciation of what can be done and how it can be implemented, I think, is the area that really needs to try to be addressed so that we can utilize the benefits that are possible with this.
Thanks, Jim.
Hey, this is Luther. I've got a quick question for you. Of the let's say the use cases specific to drilling that have not been solved yet, which one or which ones do you think are going to have the biggest impact on the industry?
That was directed to me, Luther?
Yeah.
Yep. Okay, so
Jim.
Pandora's box has just been opened, Luther. It ties a couple of things together here. And where a lot of the challenge comes in is because this answer is going to be cross-discipline. And the challenge of this is that in order to solve something that's cross-discipline, in most operating companies of any size, you have to be able to break down the silos and have the data go back and forth between, so that as you're making a decision, the impact of your tactical decision on the rig is understood throughout the company. So that, okay, I'm going to move this up 3 feet. What impact does that have on the reservoir? And so the field doesn't have that kind of data. So to answer your question specifically, it is what I would call enhanced wellbore placement, where the decisions that are being made on the rig, the implications of those are understood throughout the organization. So it's not just, hey, this zone drills faster, let's get up there. Well, yeah, that zone also doesn't produce. So you just drilled, Joe's on here, he's probably going crazy on the other end. You just drill what you call the fastest loser. And I think that is the single biggest element that would impact our industry, particularly in the unconventionals.
Yeah, thanks for that. That's an exciting real-time drilling use case, and it's certainly one that is not easy to implement, or the world would have it already.
What about, so thanks Jim, and Joe did kind of put in the chat, do investors get the value of AI? So anyone who deals with capital investment, or in those conversations, do you think that they get the value of AI? Do you get feedback, or what is the feedback from them? And then to Jim's point, drilling is ultimately responsible for production via wellbore placement.
So Joe, to your answer about investor value, if you believe Gartner, then 15th in the investors and 15% of the businesses investing in AI are getting value in the form of accelerated growth and higher net earnings, which, whether they're debt or equity investors, they're going to benefit from in those increasingly valuable companies. For the 85% that are failing to deliver value with this technology, yet spending money and committing on all kinds of resources on, no, the investors are still probably losing there.
Luther, was it you and I who had a conversation about E&P business models where wellbore placement is not necessarily priority?
Yeah, I think we've had a couple of them.
Yeah. It allows them. Could you talk just a little bit more about that? Because I think that's a really interesting one. Particularly, I see a lot of people on the drilling side around here, and there's a ton of focus on wellbore placement, wellbore accuracy, drilling faster, and for certain companies that's almost a moot point. It doesn't even bubble up on their radar as a priority.
So Allison, I'm sorry, I one little piece of that cut out, and I'm not entirely clear on the question. So would you mind just restating?
Yeah, I think we were having a conversation a couple of weeks ago about whether wellbore placement not necessarily being a priority. It allows, if they can illustrate that they are within a specific zone, then it allows them to increase their borrowing capacity.
Right. So that gets back to the implications of technology on reserve-based lending. I think it was part of the context.
Yeah, that's what we're talking about. Yeah.
And the kind of the overarching point is that when we are prioritizing business cases to invest in with technology, to make sure that we're looking at the comprehensive implications of that technology adoption beyond just the balance sheet. Many industries, just balance sheet P&L centric business cases are standard, but because of the criticality of reserve-based lending and how heavily the industry has relied on reserve-based lending, especially through this cycle of super low interest rates, whether it's a drilling use case or a subsurface mapping use case, production use case, a fracking use case, anywhere in the value chain, it is critical to look at the comprehensive implications of that to avoid some of the, I'd say, the avoidable, it helps us avoid avoidable failures. If, the technology works, everything's aligned, but then for some reason something doesn't get adopted because there's this unknown financial implication that just wasn't being discussed and wasn't out in the open from the beginning. For example, like the borrowing capability being adversely impacted if we generate more capitally efficient wells that have EURs that are all 100,000 barrels less, but generate more net cash. That doesn't necessarily put an oil company in a better position than drilling those more expensive wells that generate less net cash each, if they're getting a lot of reserve credit and they can borrow a ton of money at very low interest rates. So got to look at the thing holistically, independent of the use case across the entire value chain.
Yeah. Thanks, Luther.
Did that answer that question, Allison? I hope that
it did. That was the interesting discussion that you and I were having about what really are some of the driving decision-making factors to pursue this at all. And sometimes, and in some cases, when you look at the holistic drivers of that business, there may not be a priority placed on well replacement or whatever that particular kind of first step solution or MVP or the reason you would even go down a particular path with technology.
Yeah, and I think, Allison, a simple concept that comes out of this is what's a better well can mean something different to the board, the C-suite, the management team, and the folks in the field. And that having everyone aligned on what is a better well, specifically, within the context of a focused objective or focused initiative, is a critical part of planning that is that's getting missed too often especially on these projects that are failing.
Yeah, absolutely. So we are at about 11:35. We're about 5 minutes over. Thank all of you for hanging in there with us. This has been great discussion. We've got one comment from Dickie Hall. Jim, do you want to give him the floor, and then we'll go ahead and wrap up.
There's Dickie and Petra.
Yeah, great picture.
Sometimes I wish I was still there. I guess I'm just adding on to Jim's standpoint, because one of the paradigm things about drilling is, quite honestly, drilling, we're now really a service industry, service to the, again, as you said, providing a quality wellbore. So I think a lot of what that AI and machine learning is going to contribute is along the lines of actually what I consider well integrity, which includes wellbore placement, which includes the ability to get the well drilled with, and key piece, get casing to bottom and properly cemented so that you have a completable wellbore with minimal NPT. Because again, these wellbores, the more money it's cost you to get the well drilled up front, the bigger impact it has on your economics because of the fast decline rates. So I think those are areas, and to me, it all rolls up into wellbore quality or well integrity. I think that's where AI and machine learning are going to help, because unfortunately, horizontal drilling has been, we learn by our mistakes tremendously, and generally the mistakes cost a lot of money. So I think the idea there is you minimize them, is to minimize the mistakes. Again, also, like you said, combine the ability to deal with the reserves and where the wellbore is at, but also to give you something that a completion group can come in and do a good job of completing.
Oh, that's a really good point, Dickie. Thank you. Yeah, in fact, just last week I was speaking with a company that drilled a really fast lateral, and for whatever, so it was awesome, but due to that, or due to the speed, they put a kink in it that had significant impacts on the completion side of things, and so it ultimately wasn't a good thing that for the E&P.
Yeah, conceptually, when you think about the fact that I've had wells that just the cost for the water to frack it was more than what it cost me to drill the well, that kind of impact on what we do to set up and make it a successful completion is just magnified. Because when we mess something up in drilling, it doesn't go away.
Amen. Well, thank you, Dickie. All of you, this has been wonderful. It's about 11:38. Chris, Luther, Raji, thank you so much for joining us for this discussion today. And for all of you who joined on the attendees, thank you all for your time. We do these every other month. So our next one will be late June. Be looking for notifications about that through the IADD website and on LinkedIn throughout the course of the next month. With that, you all have a wonderful weekend. Thank you again, all of you, for joining, and we will talk to you soon.
Thank you all so much.
Thank you, everybody.
Bye. Thank you.